In this short video, I want to try to answer the question, why do we need common denominators? I think everybody sort of knows the term common denominators. A lot of people get a little twitchy when they start thinking about that. So I just want to touch real quickly on why do we need the darn things. All right, so let's start with, suppose we have, I take 1 pound and I add a pound to it, right? What have I got? Well, of course, I've got 2 pounds, right? Easy, no problem. Similarly, if I take 1 ounce and I add an ounce to it, what have I got? I've got 2 ounces, right? Easy. But what about if I take 1 pound and I try to add 1 ounce to it? Is my answer pounds, or is my answer in ounces, or what, right? So the thing is, this isn't quite as easy as the other two. I got to think about it a little bit and maybe do a little some other calculations, but it's not as straightforward. And the reason for that is because they're different units, right? They're different sizes, pounds and ounces. Similarly, let's do a distance, all right, length. Here I got a ruler. It's 1 foot. I add a foot to it. What I got, of course, I got 2 feet, right? Again, same size, both are feet, so it's no problem. Inches are the same. If I add 1 inch to 1 inch, I get 2 inches. You don't even have to think about it. It's easy because they're the same size. They're both inches. But just like with the weights, suppose I take 1 foot and I try to add 1 inch to it. So what's my answer? Is it in feet? Is it in inches? Is it in something else, right? It's not nearly as easy to figure out as when we were adding 2 feet and when we were adding inches together. So this takes a little more thinking. It's doable, but you've got to think about it. Fractions are just the same way. Suppose I take a fraction of a half and I add a half to it. They're both the same size. They're the same length, right? 1/2. If I add those two together, it's easier. I know I've got 1/2 plus 1/2. I got 2 halves, or 1 whole. Thirds are the same way. If I take a third and I add a third to it, they're both the same size. They're both thirds, right? So 1/3 plus 1/3, easy. I don't have to think about it. It's 2/3. And just like with the weights and with the lengths, they suffer the same affliction, right? If I take a half and I try to add a third to it, now this isn't as easy as the other two, right? I don't know. Is my answer going to be in halves? Are they going to be in thirds? Something else? So this has that same difficulty, right? I'm adding 2 things that are of different lengths or different sizes, right? 1/2 and 1/3, they're different sizes, so they cause me more grief. That is where common denominators come in to help us. They help us to add and subtract fractions that are different sizes. And when I say different sizes, it means the fractions have different denominators, like halves and thirds and fourths. So we saw in the example here, I was trying to add halves and thirds. All right, they're different sizes. That's where the common denominators are going to help us. Now, in a later video, we'll look at how they do that. But for the time being, I just want to cover in this short video, why do we need them? This is why we need them, because they can help us add 2 fractions that are of different sizes. Done.